Good morning, everyone. Good afternoon. So we're actually here to talk about a very important topic nowadays. So how we can use digitalization in a practical manner to really drive energy efficiency and reduce carbonization of our industries, right? So a very important topic nowadays. So first of all, I want you to think. And just reflect on this fact, right? So we have a very big and complex industrial world out there, right? So very different type of equipment, different type of networks, different type of PLCs, SCADA systems, et cetera, et cetera. So at the end of the day, how do we make it practical, right? To use digitalization in a secure manner, in a scalable way, to really bring the value that digitalization can bring. And at the end of the day, you need to think, right? So how can we not help our customers, and how the end customers even know where to start from, right? And this is where we certainly believe that digitalization is actually the right tool to bring the operational teams, all the value for our industry, right? And allow me first to introduce ourselves. So my name is Jorge. I'm the Digital Director for Industrial Refrigeration for Johnson Controls, and my colleague with me.
My name is Lars Pasgaard. I'm Product Manager for Controls and Digitalization with the Sabro factory in Denmark. So pleased to meet you all.
So, as I said, it's a big analog world out there, right? Legacy systems, existing installations, right? So what is the challenge here, right? And the challenge is very clear. So first of all, how we can connect in secure and robust way our installations, right? How can we do it in a cost-effective manner? And how can we make it in such a way that is really scalable, right? And this is where we start asking ourselves, so where do we start from, right, Lars?
Yeah, that's right. Yeah.
Right. So there are two things that we found out. First of all, certainly you need to look at the controls that you have in the equipment, right? So controlling that equipment. So that controls, if you have legacy controls, you need to bring those into the modern ages, right? So that control is controlling your equipment, so it's really running how efficiently you operate that equipment. So you need to do an assessment of what you have in the field. And on the other end, you actually need to choose the right technology partner, right? And that means someone that has practical experience and doesn't promise the world. And actually looks at what you really have, what are your specific challenges, and how, with the digital technologies and capabilities that they have, how they can support you in that process. Because it's a journey, right? Digitalizing our space is a journey, right? And here is what we need to think, what good controls actually look like, Lars.
Yeah. Thank you, Jorge. So to us, good controls is what matters really to make a difference for our customers to drive decarbonization and optimize performance and reduce lifecycle cost of the equipment. Here we have our latest child, the UNICEF 4, which is our core controller holding a vast majority of our intellectual property. Controls for us is how to make sure that the operation is maximum, the uptime is maximum of the equipment, but also how to secure that the capacity or yield of the equipment is accurate to fit the load profile for the customer. Also, how to ensure the highest possible energy efficiency of the system to also drive decarbonization. How to ensure that the customers experience the longest possible service intervals for our equipment, which will also reduce lifecycle cost. And then, not to forget, of course, that we also provide a great user experience for the ground team, the users on a daily basis, so they can be efficient in the daily work routines. But also equipment that can easily be retrofitted on existing equipment, legacy machines from Sabro, York, Johnson Controls, but also for our dear colleagues, competitor compressors. That's also possible. And then, of course, that we have not cornered ourselves. We are open to the future. and not only support integration with superior systems, but also are open to connect to more forward-looking cloud-based technologies like OpenBlue, which Jorge represents. So this is what we believe is great controls for us, and this is what we are striving to offer to our customers. So will you take it from here, Jorge, and tell us more about what digitalization, how we can achieve that?
Thank you, Lars. Absolutely. So there are a couple of things that I really picked up in here that are really important, right? So there are controls, modern controls that I can actually fit in retrofit existing units. So that means actually protecting investments from the customers, right? We cannot pretend the customer all of a sudden changes the entire equipment, right? So we need to protect those investments. So this type of controllers are at the end of the day are thought to be retrofitted in existing equipment, right? So enabling more efficient operation. So, and also that it looks to the future. So it's ready for future technologies that are not being applied in our industry today. And those solutions at the end of the day, they reside on the controller, but how we can easily connect those controllers into other systems that are open and that enables connectivity with other equipment in the field are what it will actually bring the capability to talk and correlate different equipment and actually deliver the energy efficiencies. So what actually a great technology partner looks like, right? And this is what I try to express here in a simple way. So first of all, is someone that is very assertive and transparent all the time. It's very easy for technology companies to promise the world. Everything seems possible. But at the end of the day, we really need to look backwards with experience and say how we can help the customer move forward in a practical way, right? So of course, that technology company has a track record, right? Implementing IoT solutions. So, and there is actually that plus, right? That advantage that technology partner actually has experience with physical assets, not only with the IoT world, but also with the mechanical side, right? How the equipment actually operates. And at the end of the day, what I said, knows how to listen, and the technology stack that it has is really open, meaning that it's not closed, meaning that at the end of the day, you can connect multiple equipments from different manufacturers and actually convert an analog world into a digital one, right? And of course, and it's technology to be user-friendly, right? Not just for programmers somewhere in the world, right? So this is what we try to deliver. So let's talk now about some practical cases here.
Thank you, Jorge. So the best way to give you an idea of what we are really talking about is to give you a few use cases. I will start to highlight how the framework, how we see it, what we are working with on the framework level, and then Jorge will round up with a more specific case study from a real implemented plant. This first case depicts, I will go over here, it's much better for all of us. This first case depicts how it's possible to reduce cost of ownership with a vibration-based service, condition-based service. We have a combination here of a local controller, which can be referred to as the edge controller, and in combination with OpenBlue in the cloud, we can support our customers to minimize cost of ownership based on asset protection and to maximize uptime, but also to enable our customers to efficiently plan for their service to fit into their production plans. So on the controller level, we can, in this case, monitor the vibration levels on the compressor and motor bearings and give an actual picture of what is the condition of the bearings. Then on the local controller level, it's possible for us to protect the equipment against wear, but also against the complete wreckage of the machine. So actually, at some point when the vibrations on the bearing starts to show bearing fatigue, we will in due time inform the customers or the operators of the plant that it's time to inspect the bearings. If nothing is done at some point the bearings will have reached a critical level of vibrations, and we perform a full shutdown of the machine in order not to experience a complete breakage of the equipment. So the local controller will protect the equipment, but ideally our customers would like to be able to predict how much time they have left before the equipment gets shut down, so they can plan for service and also for maybe a production stop. And this is where the cloud or technologies OpenBlue fills in with the big data and the technologies that are implemented in OpenBlue, like artificial intelligence and machine learning algorithms that will support us identify patterns, and to also, based on this big data and experience knowledge and knowledge of the bearings, be able to very accurately predict what is the remaining lifetime before it will be shut down. This will enable our customers to plan for service. So this is a case of how we can use this for planning and maximizing uptime. So please, Jorge, will you take this? Yes. This final case from my side is also a framework where we use the same framework with a local controller and OpenBlue in the cloud. In this case, to do a continuous optimization of the system. When a new plant is commissioned, the commissioned technicians, they configure the settings in the local controllers to fit the load profile of the actual plant. But nothing is static in this life, and nor is the use of the plant. Wear of the machines kicks in right from the beginning, changes to the operating conditions on the cold and hot side of the equipment. Load profile changes, customers sometimes change use of the plant and stuff, meaning that the settings that was configured right on the commission does no longer fit. It is possible on site to do constant optimization of settings, but it requires a lot of attention and a lot of time. So instead of doing that, we can support with our cloud technologies to do these predictions and to come out with new suggestions to settings which will fit the actual load profile of the system. And this again by using our applied artificial intelligence and machine learning, but also all our best practices and benchmarks with plants and machines sharing characteristics similar to the specific plant. So in this way, we can report out to our customers what the new settings should be. Maybe in the future, we will be able to push out new settings, provided our customers allow us to do it, but we are capable of doing that. In this way, we will actually be able to support our customers to reduce cost of ownership throughout the life of the equipment. So thank you, Jorge. I will leave it to you to give us the case from a real life plant, and the benefits from that. So please.
Thank you, Lars. And indeed, so this is a framework that we have actually come up with after experience, and just want to reinforce here that at the end of the day, would you trust, for example, if you had a car, an electric car that autonomously drives itself, would you trust that artificial intelligence to be in the cloud, right? What happens if you're going through a tunnel and there is no internet connection? So in the same way, you would not trust entirely to run your artificial intelligence, your machine learning, and all that capability at the cloud. You have to do it at the edge, right? And therefore, I reemphasize, you need great controls, but you also need the great technology partner that has the right technology stack to really be able to run artificial intelligence at the edge and use the cloud technologies to supplement the controls that you have at the edge, right? To augment that capability. And we believe certainly that we have both things as Johnson Controls. And just to give you real life samples, a real implementation. So this is an installation done by the Stanford Central Energy Facility in the US. And here is actually a plant that is serving 360 buildings and actually is totaling 12 million square feet. So it's providing a cooling load of 75 million ton-hour per year. And it's also providing a heating load of 2.2 million actual mega BTUs per year. So it's a huge plant. But if we look, and we actually have the paper here from the District Energy Association, the IDA Association from the US, which we'll certainly be more than happy to share with you if you leave us your contact details. But at the end of the day, what you achieve, by having these sort of systems, right? Great controls at the edge and great capability also at the cloud, the right technologies combined. So you look at those results. So $500,000 US actually of savings cost per year, right? And look at efficiency as well. So certainly a great improvement in efficiency. So at the end of the day, at the beginning, it's certainly a very unknown road for all of us, right? What are we going to actually achieve by implementing these technologies? And that's, again, the message that I provided earlier. It's a journey, right? And it's a journey. So there will be too many unknowns. But until you don't do a proof of concept and you don't have that technology partner that carries you with the experience along the way, then you will end nowhere, right? So we'll be more than happy, as I said, to share the paper from the association with you so that you can actually look at the details of this plant. But at the end of the day, as I said, great controls at the edge combined with the right technology partner is what actually will guarantee results. And it will certainly, I will leave my colleague to close here.
Thank you, Jorge. So I have the final words. What we have presented to you is our take on how we can support our customers to significantly reduce the cost of ownership throughout the lifetime, but also to secure the operation, the uptime of the equipment, which in terms is to secure their production, but also significantly, of course, in this notion to reduce the carbon footprint of the operation. So this is what we aim to, and hope that you have got the idea of what we are working with to support our customers doing this. With those final words, we will encourage you to come see us in our booth, where we will be for the rest of the day until we close, and where we can talk much more about our capabilities on the control side, on the edge, but also in the cloud. And thank you for listening to us. Hope to see you all again in a couple of years. Thank you.